Section 13.3, first part of it, evaluating trig functions of any angle. What we're going to use is triangles within a circle in order to determine these trig functions. So we've already determined that the functions are sine, cosine, tangent, cosecant, secant, and cotangent. So what we're going to do, we've used those trig functions in relation to the sides of triangles. Now let's put that triangle onto a coordinate plane and see how that works. What I've got here is a circle with a radius of r, and theta is the angle that's opening upward. Now what we can do is we can take the terminal side of that angle and the point where that angle crosses the circle to create a right triangle. And what that does is allows us to use those the formulas for the for the trig functions that we've already determined. So when we do that, when we open it up, we've got this point x, y, and we've got our distance r, the radius of the circle. And so this point now, we actually have the opening of this angle here, but we have a triangle that is formed. And so what we can do is we can determine that this triangle results in the sine of theta being y over the radius. So y is the distance away from the center of the circle. So this distance and the radius. So because what happens now is that we've opened up, and so we've got opposite over adjacent. So sine is the y value over r. Cosine is going to be the x value over r. And then the tangent is the y value over the x value, and then cosecant, secant, and cotangent are just flipped. So so what happens is we've got the y is our distance up and down, so the sine is the opposite, which is the y, over the hypotenuse, which is the r. And then this the cosine is going to be the adjacent, which is this x value over the r. So that's where those parts are coming from. Okay, so let's take that, all right? You can look at it later and make sure you understand where it's all coming from. Let's do something with that now. So if I want to evaluate the trig functions at the point, and so what I'm saying is, and I didn't write all the instructions out, what will happen is this is a point on the terminal side of the angle that opens, theta that opens from the center, from the origin. So we know that the angle, or the point -9, -40 is going to be in the third quadrant. So we're going to have -9, -40 is going to be here, and then it's going to create this triangle. And so now you say, well, that's fine and dandy, but we've got x and y, right? -9 and -40 are x and y. That's easy. But we don't have the radius of the circle. Well, guess what? You know how to find it because of good old Pythagorean. So what we're going to do is we're going to take we know that because this is -9 is our x, we know that this side is -9, and we know that this side is -40. So we just take the -9 squared plus -40 squared, and that's going to equal our radius squared. All right, so 9 squared is 81, and 40 squared is 4 times 4 is 16 with 2 zeros, and so that's what, 1681, and that's radius squared, so the square root of that is 41. So our radius equals 41. So now we already have all the parts we need. We have x equals -9, we have y equals -40, and we have radius equals 41. Once we have those three parts, now it's just a matter of plugging them into what we know about the six trig functions. So the sine is going to be y over r, so you find y is -40 over r, which is 41. Cosine is x over the radius, so x is -9, and that's over the 41. Tangent is going to be the y over the x, so -40 over -9 becomes positive, so 40 over 9 is your tangent. Cosecant is simply going to be the sine flipped. You can either go radius over y, or you can simply use That's why I put them side by side. You can use these three trig functions and just flip them to get your cosecant, secant, and cotangent. So this is going to be negative 41 over 40. This one is going to be negative 41 over 9, and this one is going to be 9 over 40 for the cotangent. All right? Easy enough? So really the hardest part of that is finding your radius, and that's just using Pythagorean. Okay? Now, that is fine and dandy and great, but we don't always have a nice neat circle. We don't always have a point. What we need is we need a way to evaluate in more than one without a point on the circle. And so what we have is called a unit circle. So you need to get very familiar with the unit circle. The unit circle is your friend, okay? In Trig, you live and die by the unit circle. And I have copies of them for you to give you in class, so you can start by drawing one and getting the general idea. But I'll have, there's lots and lots of information. We're going to add a little bit of information more and more and more as we go along here. But what you need to know is the reason we call it a unit circle is because the radius is a unit. The radius is equal to 1. And if the radius is equal to 1, if you'll look, if the radius is equal to 1 on the sine and cosine, that simply means that the sine is just going to be, or is just going to be y. Zoop. And the cosine is just going to be x. Oh, man, I made a mess. Okay? And the tangent is still then y over x. All right? So then your cosecant, secant, and tangent would be flipped. So your cosecant would be 1 over y. Your secant would be 1 over x, and your tangent is still x over y. All right? So the reason this comes in handy is when we want to use the unit circle to evaluate these trig functions. What I'm going to do right now, first, we're just going to use what's called the quadrant angles. We're going to practice just on the easy, the quadrants, the 90, the 180, the 270, and then the 360 or the 0. All right? So what we're going to do is this. Let's evaluate the six trig functions. I chose more difficult ones. In the book, it has very simple examples, but I chose more difficult ones because your homework has more difficult ones. And where does this come from? What? Why? So what you're doing is this. When you want to evaluate theta equals 5 pi over 2, this 5 pi over 2 is in radians, and actually maybe, you know what, let's start with the degree measurement because radians are a little bit more difficult. Let's start with the degree measurement. So 630 degrees is going to be, 360 is one whole circle, right? So 630, you're going to go around the circle a little bit, but you can figure out where you end up by taking the 630. Well, let's just subtract 360 from it. And we end up with, oh, look, 270. Okay, so remember when we circle around, what we care about is that terminal angle. All right, so what happens with this 630 degrees, this angle opened all the way up around the circle, and then it opened again 3/4 of the way around. So what we've done is we've ended up at 270 degrees. And you're saying, well, that's fine and dandy, but how does this help us? What you need to remember is that if this is a unit circle, the points where this circle are going to cross the quadrant, this point is going to be 1, 0. All right, it's 1 to the right. It didn't go up or down. This point is going to be 0, 1. It didn't go left or right. It went up 1. This point where the 180 degree line crosses the circle is going to be -1, 0, and this point is 0, -1. All right? So is it starting to click? So now you have an x and a y at those places. So what we want to do, if I want to find the trig functions at theta equals 630, first I have to put that 630 somewhere on my circle. So I have to figure out at what point is it going to stop if it's going in a circle. So take the 360 off and we end up with 270. All right, so the 270 is right here. So that's 3/4 of the way around. So it's this point. And so all we do is we're going to do the sine, cosine, and tangent at 0, -1. So the sine is going to be y, and my y is -1. Done. Cosine is x, and x is 0. Tangent is y over x. So now we have to be careful because y is -1 and x is 0. So that would be -1 over 0. Now you should be going, wah, 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 don't do this, don't do this, all right? You cannot divide by 0. If 0 is in your denominator, then it is undefined. So the tangent at 270 degrees is undefined. All right, if 0 is in your denominator, undefined. Okay, the cosecant is going to be the reciprocal of sine, so it's going to be 1 over y, and we said that y is -1, so it's going to be 1 over -1. 1 over -1 is still -1. And the secant is going to be 1 over x, so it's going to be 1 over, and the reason we're flipping, the reason we can say 1 over is because, remember it's the radius over y and the radius over x, but our radius in this circle is equal to 1. That's why we can do this with all of those. Just flip it and say it's 1 over this. All right? And that's why we can simply say that the sine is just y. Where was I? I got distracted. Secant is x, 1 over x, and x is 0. So we have 1 over 0. So the secant here is undefined. And then the cotangent is going to be flipped, so it's x over y. X is 0 over -1. 0 on top is okay. That means that my cotangent is just 0. All right? So with the degree measurements, that's easy. Guess what? With the radians, it's just as easy. It's just a matter of wrapping your head around using pi as your measurement instead of the degrees. So what we'll do with this is we'll say, okay, theta is 5 pi over 2. So what we know is that from 0 to 180, that's pi, all right? Because 2 pi is all the way around the circle, because that's how you find the circumference of a circle is pi times 2 pi r, all right? And our radius is just 1. So twice pi is all the way around the circle. So halfway around the circle is just 1 pi, all right? This is where these numbers are coming from. Once you get it, it's okay. I don't have to keep describing it. So halfway up is 90 degrees, or pi over 2, because pi was all the way, so pi over 2 is straight up and down. And, oh, I didn't put it on here. So this is, where's my black marker? 1, 2, 3 pi over 2 is straight down. All right, so, all right, and so this one would be 4 pi over 2, which reduces to 2 pi. Okay, I did it right. Whew. All right, my brain is still trying to turn into radians also. So what we need to do is find the place where 5 pi over 2 is. So 5 pi over 2. So with these quadrantal angles, with each of these quarter of a circle, each quarter is pi over 2. It's half of a pi, all right? And we have 5 halves of pi. So you might count it differently, but here's what I do. I say, well, I'm starting here. Here's 1 pi over 2, 2 pi over 2, 3 halves, 4 halves, 5 halves. All right? So 5 halves gets you right back over to pi over 2. It's going to end at the same place, so their trig functions are going to be the same. All right? So we're looking for pi over 2, and now once we know where it is that we're talking about, now we simply figure the trig functions. So we're dealing with the point 0, 1. So the sine of that, the sine is y, and y is 1. So the sine at pi over 2 is 1. Cosine is going to be the x. The x is 0, so cosine is 0. Tangent is y over x, so 1 over 0 is undefined. Cosecant is going to be 1 over the sine. 1 over 1 is just 1. Secant is going to be 1 over the cosine. 1 over 0 is undefined. And cotangent is going to be, well, the tangent was undefined. So it was 1 over 0. So the cotangent is going to be 0 over 1, which is now defined. All right? So that's all we'll do today. The idea right now is to start wrapping your head around those different trig functions and what they mean and where they are, and start getting familiar with the unit circle. Make sure you know these four points on the circle. We're going to add some more next time. Good luck. See you soon.